All right, in 8.3 we learned about the trig ratios, SOH CAH TOA, sine, cosine, and tangent. We learned how to identify the opposite side, the adjacent side, the hypotenuse, and we represented those as fractions or decimals. And today we are actually going to use the ratios to solve for missing sides. We've never been able to do this before, so let's just jump right into it. All right, so up above it says steps for solving for a side. Number one, you're going to stand on the angle given. This is just the way I like to do it. Remember, this is called the reference angle or the point of view. This is kind of where you're looking from. We need to label the triangle H for hypotenuse, O for opposite, and A for adjacent. So H is going to represent the hypotenuse. O is going to be our opposite, and A is going to be our adjacent. But we'll just use H, O, and A to make our life a little easier. Then we're going to have to choose the correct ratio. This will be the little bit tougher part today. We're going to have to choose whether we have sine, cos, or tan, and then finally set up and solve the equation. So there's multi-steps to doing these. And then of course, number 5, does the answer make sense? Because remember, you should be able to look at a triangle, and once you know the angle measures, you should know who the biggest side is and who the smallest side is based off of the angles that they are across from. All right, so let's jump right into this. Number 1, find the value of x. So we're trying to find this hypotenuse side right over here. We cannot use the Pythagorean theorem because we have 2 missing sides. So Pythagorean theorem is only good if you know 2 out of 3. We only have 1. So stand on the angle given. Well, the angle given is 57 degrees. So this is where I'm going to put my guy. And everything is labeled, step 2 is labeled based on that guy's position. Now, the easiest side to always find is the hypotenuse. The hypotenuse is always directly across from the right angle, and it's always the largest side. So there's my hypotenuse, x is. Then the next one I always do is I look across the triangle to the side that's opposite me, and that is the opposite side. And then what you're left with, you are left with the adjacent leg, or the leg that I'm standing on over here, the one that's right next to me. So we have adjacent leg, opposite leg, and hypotenuse. Now, part 3, choose the correct ratio. Well, when I look at this drawing and I look at the measurements that I have, they don't give me the adjacent side, and they don't put a letter in the adjacent side. So basically, I don't need this A. I don't need this for this problem. But what I do need is I do need this x, and I do need this 11 that they gave me. So which ratio involves the O, opposite, and the H? Well, the ratio that involves the opposite and the hypotenuse is sine, O and the H. So I'm going to set up a proportion. So let's set up a proportion. So the sine, when standing at 57 degrees, is always equal to the opposite leg, which is 11, over the hypotenuse, which is x. Now, there's a couple different ways to solve this equation. I'm going to basically solve it like a proportion. So I'm going to put a 1 underneath the sine of 57, and I'm going to cross multiply. So let's cross multiply here. 1 times 11 is 11. X times the sine of 57, always put the sine or tan or cos at the back side. So this is going to be x times the sine of 57 degrees. And now I'm just going to use algebra. Now I'm going to solve the equation. So to get x by itself, I'm going to do the opposite of this multiply. I'm going to divide by the sine of 57, and I'm going to divide by the sine of 57. And what's left is I will have x equals, and now I want to show you how you're going to punch in this 11 divided by the sine of 57. So I'm going to go to my document camera here, and I'm actually going to punch in 11 divided by the sine of 57 to kind of help you out. So let's open this guy up. So zoom in a little bit. So I'm going to go 11, turn it on might help. I'm going to go 11 divided by the sine of 57 degrees equals. And it might be a little bit hard to see there, but I get an answer of 13.11. So rounding to the nearest tenth, that would be 13.1. So let's back out of this. All right, so going back to my screen, when I divided that out, I got 13.1. 13.1. And so I want to look and see if that makes sense. So I go here to my picture and I have 13.1, and that does make sense because the hypotenuse should be the biggest side and this other side over here is 11. So I believe 13.1 is a good answer. Now if I were to get a number smaller than 11, I would know that something went wrong. All right, let's move a little bit quicker here and let's come over here to number 2. So I'm going to scroll down a little bit and do number 2 using kind of the directions up above. So this time I'm trying to find x. They tell me what the hypotenuse is, and the angle given is 44 degrees. So that's where I'm going to put my guy. That's my reference angle. I'm going to stand right there. So this is my reference angle. And I label the triangle. Well, the hypotenuse is always across from the 90, so that's over here. The opposite side is across the triangle, and the adjacent leg is the leg I'm standing on. Well, now when I look at this one, and I look at the measurements that I have x and I have 10, I don't need that opposite side. So now I got to find the correct ratio that has the a and the h. So I'm thinking about my SOH CAH TOA, and I'm like, hey, there's the one with the a and the h. So I'm going to use cosine. So let's set this thing up. The cosine, when standing on 44 degrees, is the ratio of the adjacent leg over the hypotenuse. And again, there's right now some kids would just multiply both sides by 10, and that's fine if you want to do that. If you see that, go ahead and do it. I'm going to actually always put a 1 under it and cross multiply because it seems to help some people out. And we've been doing a lot solving triangles, so I'm going to just kind of keep that rolling. So let's cross multiply. 1 times x is x. The cosine of 44 degrees multiplied by 10. Now be very careful here. Always put the cosine and the degrees at the end. So punch in 10 times the cosine of 44 degrees. You do not want to punch in cosine of 44 degrees times 10 because sometimes your calculator might think you're looking for the cosine of 440 degrees, which would be totally different. So don't do that. Always put the number in the front. And now I'm going to go to my calculator and I'm going to punch in 10 times the cosine of 44. So let's pull this little guy back up here and clear him out. 10 times the cosine of 44 equals, and I get 7.19. So we're going to round that to 7.2. 7.2. So let me go over here and get this back out of here. So that came out to be 7.2. And now I want to ask myself, and I probably shouldn't say it's equal because it's approximately, ask myself if that makes sense. Yes, it does, because it is smaller than the hypotenuse, so that could be a decent answer. All right, let's give number 3 a shot. And right now might be a good time that I kind of jump in and I kind of warn you about the calculator and what's going on with the calculator. Double check before you get too into this. Double check that your calculator is in the correct mode. If you're using the TI-30 like this that I issued earlier this year, The mode button is right here. It says DRG. All right, that button, maybe I'll do it in red, but this button right here will tell you what mode you're in. So I'm going to hit the DRG, and I have a choice there on the top, and it looks like my image isn't really keeping up here. This is the first. There we go. So if you notice at the top, you have DEG, RAD, and then you can't really see it, but if I go out of the light a little bit, GRD. But we're always wanting our calculators to be in DEG mode. That's degree mode. So if you hit this DRG button, it should tell you what mode you're in. I'm going to go ahead and I'm going to quit out of that. So I'm just going to exit out if I can find it. Just hit clear, and I'll go back to where we were beforehand. All right, let's go down. Let's pick up number 3. And see if I can maybe leave this calculator up over the side. I'm kind of just playing around doing this for the first time in this video, so bear with the technical difficulties. Alright, so this triangle, I need to figure out what x is. The angle given is 51, so I put my guy on the angle given. So I'm standing here at 51. I label the hypotenuse because that's always across from the 90 degrees. I'm going to label opposite, so the opposite side is over here, and the adjacent leg is the leg right next to me or touching me. And now when I choose the ratio, because again I have a choice, I can either choose sine, cosine, or tangent. Well, in this drawing we don't need the h. There is no variable or no number there, so we do not need the h. We need the a and the o. So looking through, this looks like a job for tangent. Tangent involves the a and the o. So let's set up this equation. The tangent, when standing on 51 degrees, is equal to the opposite over the adjacent. Okay, because remember, tan of any angle is the opposite over the adjacent. That's what this symbolizes here. So we set it up, and I'm going to set it up as a proportion again, and I'm going to cross multiply. So I get x equals 10 times the tangent of 51 degrees. And I'm going to punch this in my calculator over here. So let's just clear this out. And it looks like I have to kind of tap on that little screen over there. 10 tan of 51. So 10 times the tangent of 51 degrees equals, and I get 12.34. So we're going to call that 12.3. So I'm going to come back over here, and so x equals 12.3. And now I always want to put it back in and see if it makes sense. 12.3. Well, I don't have the hypotenuse, so I can't really say, oh, it's smaller than the hypotenuse, so it must be good. But I can do this. If I look at this triangle, if the corner here is 90 degrees and this is 51, this guy must be 39 because it has to add up to 180. So now I can check and make sure that the smaller side is across from the 39 and the larger side is across from the 51, and that's legit. So it looks like 12.3 is a pretty good answer. All right, let's take a look at number 4. Number 4, slide this guy over to this side right now. And I'm going to kind of back out a little bit. It's getting a little bit blurry. Yeah, bear with me. That's, at least you can see my keystrokes. So I'm going to come up here and I'm going to go to my new picture, and I'm looking for x. I put my guy on the angle that's given, which is 59 degrees. I label my sides. I label the hypotenuse. It doesn't look like I'm going to need the opposite over here, so I'm not even going to write it down. And then I have the adjacent. So again, who am I using? SOH CAH TOA, and it looks like I have A and H, so I need cosine. He's the man for the job. So let's set this one up. We are going to do the cosine when standing on 59 degrees equals the adjacent, which is my x, over the hypotenuse. So I put a 1 underneath here, and I'm going to do a little cross multiplying. 1 times x is x. 17 times the cos of 59. Again, do not put cos 59 17, or there's a potential to be a problem. And now I'm going to go to my trusty calculator over here and see if I can jump into calculator mode for a second. So 17 times the cos of 59 equals, it looks like 8.75. I know that's pretty rough to see for you guys at home. I'm going to back out a little bit. Oh, maybe closer was better. I don't know. But 8.75, so let's just call that 8.8. So let's write that down. X equals 8.8. I write down 8.8. And that makes sense because the hypotenuse is 17. So this leg should be smaller. So I think it checks out. I think it's okay. Now the only thing that I want to show is on a different calculator. Let's say I'm doing 17 times the cosine of 59. On a different calculator, I'm going to bring in one of the ones that I kind of have out in class sometimes. 17 times the cos of 59. So on this calculator, I know it's kind of rough to see the keys, but in order to do trig on this one, there are no sine, cosine, or tangent keys on the calculator. So you have to get in the trig menu, and the trig menu is right underneath. It's right here underneath this pi key, or above the pi key. So I need to hit second up here at the top, second pi, and that will get me in the trig menu. Man, that's really blurry. I apologize, but I don't really know how to get this thing to focus any sharper on that. And the first one says sine, then cosine, then tangent, and you can just use your arrow key to go up or down. So I think we were doing 17 times the cos of 59. So I'm gonna back out of this. I'm gonna quit out of this, and I'm gonna go 17 times. Now for cosine, I gotta hit second pi, scroll down to cosine, and then hit 59, and hopefully I get 8.8 like I did before. 8.75 or 8.8. Now this one's a little bit easier to see what mode you're in. You can just hit the mode button, and right at the very top it'll say DEG or RAD. Just make sure that the DEG is highlighted and hit enter, and you'll know you're in degree mode. Now I know that cell phones have all the different trig stuff on them too. The problem with that is you can't really use your cell phone on your tests and quizzes. However, I know my iPhone, when I turn it sideways, and it looks like you can't even see the iPhone screen, but my normal calculator on my iPhone, when I look at it, I don't see sine, cos, or tan, but when I turn it sideways, more functions pop up, and you can see sine and cos and tan on that one as well. But if you have any questions on calculators, just show me in class and we can figure it out. All right, I think you have enough in your arsenal now to do the 8-4 practice. See ya.